Hello everyone, welcome back to Diverse Domain Discovery. My name is Abhinav and in today's video we will discuss the generations of computers. The evolution of computers over the decades can be comprehensively examined through the lens of different generations, each marked by distinct technological milestones. These generations represent significant advancements in the hardware, design, and computing capabilities, showcasing the relentless pursuit of innovation in the field of computer science. The journey spans from the massive room-filling machines of the first generation to the portable, powerful devices of the present day. Let's delve into the detailed exploration of each generation. First generation computers. These were developed in the 1940s and 1950s for the earliest electronic computers. These computers were characterized by the use of vacuum tubes and large physical size. They were primarily used for scientific and military purposes such as the calculations for scientific research and code breaking during World War II. Key features of the first generation computers include vacuum tubes, large size, limited memory, and high power consumption. Vacuum tubes. First generation computers used vacuum tubes as their primary electronic components. These vacuum tubes acted as switches to perform calculations and store data. Large size. First generation computers were large and required dedicated rooms for their operation. They often filled entire rooms and required extensive cooling systems to prevent overheating. Limited memory. First generation computers had limited memory capacity compared to modern computers. They relied on punch cards and magnetic tapes for data storage. High power consumption. First generation computers consumed a significant amount of power, often requiring their own dedicated power supplies and cooling systems. Despite the limitation, first generation computers laid the foundation for modern computing technology. They paved the way for the development of more advanced and efficient computer systems in subsequent generations. Examples of first generation computers include ENIAC, the Electronic Numerical Integrated and Computer. The first general purpose electronic digital computer was a landmark first generation machine. UNIVAC 1, Universal Automatic Computer, designed for both scientific and business applications, was the first commercially produced computer. Second generation computers, which emerged in the late 1950s and lasted until the mid-60s, marked a significant advancement in computer technology. These computers were characterized by the use of transistors instead of vacuum tubes, resulting in smaller and more efficient machines. The key features and advancements of second generation computers are transistors, magnetic core memory, batch processing, and programming languages. Transistors. The use of transistors instead of vacuum tubes made second generation computers smaller, faster, and more reliable. Transistors were made of semiconductor materials such as silicon or germanium and could perform the same functions as vacuum tubes but with much greater efficiency. Magnetic core memory. Second generation computers used magnetic core memory for data storage. Magnetic cores were small rings of magnetic material that could be magnetized to represent binary data. This memory technology was faster and more reliable than the mercury relay lines used in the first generation computers. Batch processing. Second generation computers introduced the concept of batch processing, which involved grouping similar tasks together and processing them as a batch. This improved efficiency by reducing the time wasted on manual input and output operations. Programming languages. High-level programming languages such as COBOL and Fortran were developed during the second generation. These languages made it easier for programmers to write and understand computer programs, leading to increased productivity and software development. Examples include IBM 1401, an early transistorized computer widely used for business data processing; UNIVAC 1107, known for its scientific and engineering applications. This computer showcased the transition to second generation technology. Third generation computers marked a significant advancement in the technology with introduction of integrated circuits and further miniaturization. These computers were faster, more powerful, and more reliable than their predecessors. They played a crucial role in shaping the modern computing landscape. Here are the key features and the advancements of third generation computers, which are integrated circuits, further miniaturization, increased speed and power, and reliability and stability. Integrated circuits. One of the defining features of third generation computers was the use of integrated circuits. Integrated circuits are small electronic circuits that are etched onto a single chip of semiconductor material, typically silicon. These integrated circuits replace the bulky and unreliable vacuum tubes used in the early computers. The use of integrated circuits led to significant improvements in speed, efficiency, and reliability. Third generation computers were also characterized by further miniaturization of components. This miniaturization was made possible by the development of smaller and more efficient integrated circuits. The reduction in size allowed for the creation of smaller and more compact computer systems. This advancement paved the way for the development of portable computers and eventually laptops and smartphones. Increased speed and power. Third generation computers were significantly faster and more powerful than previous generations. The use of integrated circuits and advancements in semiconductor technology allowed for higher processing speeds and increased computational power. This enabled more complex calculations and data processing tasks to be performed in a shorter amount of time. Reliability and stability. The introduction of integrated circuits in third generation computers greatly improved the reliability and stability. Integrated circuits were more resistant to damage and failure compared to vacuum tubes, resulting in more reliable computer systems. This increased reliability allowed for longer periods of uninterrupted operation and reduced the need for frequent maintenance and repairs. Examples of third generation computers are IBM System 360, a family of mainframe computers that introduced a range of compatible models. DEC's Pre-Programmed Data Processor 8, a widely used mini-computer known for its compact size and versatility. Fourth generation computers. Key features and advancements. Microprocessors. The development of microprocessors revolutionized the computer industry. These integrated circuits contain the central processing unit or the CPU on a single chip, making computers smaller, more powerful, and more affordable. Personal computers. Fourth generation computers introduced personal computers or PCs that were designed for individual use. PCs became more accessible to the general public, leading to a significant increase in computer usage and adoption. Graphical user interface. Graphical user interface became more prevalent in fourth generation computers, allowing users to interact with the computer using icons, menus, and windows. This made computers more user-friendly and intuitive. Networking and Internet. Fourth generation computers saw advancements in networking technology, enabling computers to connect and communicate with each other. The development of the Internet further expanded the capabilities and connectivity of computers. Examples of fourth generation computers are Intel 4004, the first commercially available microprocessor, marking the beginning of microprocessor era. IBM PC, the IBM personal computer, a landmark in the history of personal computing, became a widely adopted standard. Fifth generation computers. Key features and advancements are artificial intelligence, advanced parallel processing, natural language processing, and expert systems. Fifth generation computers are characterized by advanced AI capabilities, allowing them to mimic human thinking and problem solving. Advanced parallel processing. These computers leverage parallel processing techniques to perform multiple tasks simultaneously, resulting in faster and more efficient performance. Natural language processing. Fifth generation computers can understand and process human languages, enabling more intuitive interaction and communication. These computers incorporate expert knowledge in specific domains, allowing them to make informed decisions and provide expert-level recommendations. Examples include Cray-2, a supercomputer notable for its use of VLSI technology and parallel processing capabilities. Modern smartphones. Devices such as iPhone and Android smartphones exemplify the portability and computational power of fifth generation computing. So these were the different generations of computer. Thank you for watching.